Alright, what is a logarithmic function? A logarithmic function is a function that kind of looks like this. So we say f of x equals log b of x. And sometimes you'll see y instead of f of x. Alright? B is the base. B can be an integer. So b is an integer. Now, it's important to understand that logarithmic functions were created or found or in, I don't know, I want to say necessarily created because they were already there, but they were created very similar to radical equations, where they're created in order to solve exponential functions. So their main purpose in our neck of the woods, now they use it differently in calculus and stuff like that, but we will use, we will use log to move the variable out of exponents. Out of the exponent. All right, so we last week or yeah, early this week and last week we talked about exponential functions. So, how do logarithmic functions compare to exponential functions? They are inverses of each other. Keyword today is going to be laney. Keyword is laney. That's who's being very loud in case you're wondering. Now, this is why I put this here. It's actually from your hint page, but it's something we use quite a bit when we're talking about log. It is slightly different than the function I wrote over here. So if you notice, these are not the exact same. I kind of changed the variables around, and I did that on purpose so you guys can do this changeover idea that might ever happen. So they are inverses of each other. It means that they can be, just like you can rewrite addition and subtraction by changing a couple slight things, you can also rewrite a logarithmic function as an exponent and an exponent as a logarithm. It's kind of important to do, so I think that's really important to understand. It's probably the biggest idea, is that's why we do this. Now, number 3, it says compare logarithmic. It should say compare common. So the word common should be in there, because any log can have any number of base. So if you see this b right here, that could be any integer you want, any positive integer. So I could have 1 base 1, base 2. So base 2 would be something that you've seen before if you know anything about computers. That's their operating language, is in base 2. Everything they do is zeros and ones. And then base 10 is what we count in. So we're always used to base 10. And because of that, we're used to common logarithms, so that's going to be base 10. That's so common that when you press like in your calculator, like from your calculator, they don't write the number 10. There is like the number 10. If you ever see without a base written, that means base 10. So if there's no base here, that means it's base 10. It's a common log. Natural log is another idea that they use a lot. In nature, it's a number called e, and we'll talk about that another day. But so natural log has base e. So you'll never see anybody write this usually, where they have this little e here. So that little e right there, nobody will probably ever write that. They'll write this instead. So both of these have buttons in your calculator, and that's the difference between the two. All right. There'll be a way that you can take any base, whether it's base 3, base 4, and it's super important to put it into base 10, because base 10 you can use your calculator. The only time you can use your calculator is whether it's in a common logarithm or a natural logarithm. So that's another big idea. So compare these two. These two are the only two bases we can use our calculator.